Hello friends, in previous video we have discussed about different zone reach of a transmission line for a transmission system as shown in this figure for line segment AB at substation A and for P442 relay, where zone 1 is equal to 22.67 ohm and zone 2 is equal to 35.42 ohm and zone 3 reach is 68 ohm and zone 4 reach is 2.86 ohm and the line angle is 70.75 degree. Now in this video I will discuss about importance of different resistive reach for face to face fault and also face to earth fault. Now as per different zone reach and the characteristics angle of transmission line, that is 70.75 degree, we plot the impedance diagram for RX plane as shown in this diagram. The zone 1, zone 2, zone 3 are the forward zone and zone 4 is the reverse zone. Now in this figure for transmission line ABC, ABC are the three phases of the transmission line. A fault occurs at point F in between phase A and phase C. For this fault, the fault current will pass from conductor B phase to the fault point F via arc resistance, that is in between B phase to C phase, and return to the conductor C phase. So we should consider the arc resistance to calculate the accurate distance of the distance relay. Now in between transmission line A and B there exist two circuits. In the upper circuit a fault occurs at point F and fault current feed from substation A is IA and fault current feed from substation B is IB. Now from substation A end the relay sends the voltage VA, which is equal to ZL into IA. ZL is the impedance from substation A end to up to the fault point F, plus IA plus IB into RF. RF is the fault resistance. If it is a face to face fault, it is nothing but arc resistance and also the object of the resistance. Now our motive is to calculate the ratio, that is VA by IA, that is equal to ZL plus 1 plus IB by IA into RF. Now there are extra quantity in this equation, that is 1 plus IB by IA into RF. Now IB by IA is called the infit factor. Now if fault point is located more than half of the distance, then IB should be greater than IA if both the fault MVA of the both the substation is equal. Now if fault point is located in the zone 2, then this infit will increase. Now consider a fault occur at zone 3 distance from substation A end for transmission line in between B and C. For simplicity we consider the impedance of the transmission line in between AB is 100 ohm and for BC is 100 ohm, and fault occur at point F, which is just midpoint of in between transmission line B and C. Now this fault current is fed from all the substation, that is substation A end, B end and also D and C end. From substation A end both the circuit fed the fault current as equal to IA, and from substation D end it is ID, and substation C end it is nothing but IC, and from substation B end it is 2IA plus ID. if the substation B end has no source. So fault voltage sensed at substation A end at relay at substation A end is equal to B equal to IA into 100 plus 50 into 2 IA plus ID plus RF into 2 IA plus IB plus IC. So our motive is calculate that is the ratio of voltage by current which give the impedance of the fault location, that is VA by IA is equal to 100 plus 50 into 2 plus ID by IA plus RF into 2 plus IB plus IC by IA. So we can see that the actual impedance is 150 ohm from substation A end, but relay will see the fault point at further end due to infit factor from different substation. So we must give the resistance reach for different zone, that is for zone 3 the resistance should be greater than that is given for zone 2 and that is given for zone 1, that is R3 phase should be greater than R2 phase and that should be greater than R1 phase. Now what will happen for phase 2 earth fault? If a phase 2 earth fault occur as shown in this figure, a phase 2 earth, that is blue phase 2 earth fault occur due to tree touching in the transmission line bottom conductor, that is blue phase. There will be the fault current will passing from the point F, enter the ground via the tree, and it will divide into two paths. One path will enter the ground, that is IF1 via tower footing resistance and via tower body to the ground wire, and it will reach the source, that is the nearby substation. Another part, that is IF2, that is in the another tower and via tower body and via ground wire to the far end of the substation. If the fault point is located at a distance nearer to the local substation, then IF1 should be greater than to IF2 provided the fault MVA for both the substation is same. So what should be we consider for resistance reach here for phase 2 earth fault? Here are arc resistance plus tree resistance of the tree which is a variable quantity, and plus tower footing resistance. Now due to infit factor for different zone, here also the resistance reach given for phase 2 earth fault for zone 3 should be greater than that is provided in zone 2 and that is provided which should be greater than that is provided in zone 1, that is R3 phase 2 earth should be greater than R2 phase 2 earth and which is greater than R1 phase 2 earth. Now for earth fault a factor is introduced which is called a residual compensation factor or KZ. Now a diagram has been shown where a earth fault occur at point F. If it is earth fault occur at for red phase, then the voltage sensed at relay which is VR is equal to sum of all the sequence component of the voltage, that is positive sequence voltage, negative sequence voltage at zero sequence voltage, that is equal to V1R, V2R and V0R. Now V1R is equal to I1 into Z1. Z1 is the positive sequence of the impedance of the transmission line up to the fault point F, and Z2 is the negative sequence impedance of the transmission line up to fault point F, and Z0 is the zero sequence impedance of the line up to fault point F. Now for transmission line, Z1 is equal to Z2, and therefore the equation comes as I1 into Z1 plus I2 into Z1 plus I0 into Z0, that is equal to Z1 into I1 plus I2 plus I0 into Z0. Now we want to express the equation in terms of Z1. Now the fault occur in the rate phase. Here rate phase current is equal to sum of the all the component of the current, that is I1 plus I2 plus I0, or we can express it in terms of I0, that is equal to 3 I0. Now it is VR is equal to Z1 into IR minus I0, where I1 plus I2 is equal to IR minus I0 plus I0 into Z0, that is equal to Z1 into IR plus I0 into Z0 minus Z1. Now VR is equal to Z1 into IR plus I0 into Z0 minus Z1. Now we want to calculate the ratio of voltage by current sensed by the relay. That will give the impedance of the transmission line up to fault point F. That is VR by IR is equal to Z1 plus Z0 minus Z1 by 3. Now that is equal to Z1 into 1 plus Kz, where Kz is equal to K0 minus KZ1, Z0 minus Z1 by 3 Z1. It is called residual compensation factor Kz. The value is given by zero sequence impedance minus positive sequence impedance divided by 3 into positive sequence impedance. Let us take a simple example for a transmission line as shown in this diagram, where source impedance for positive and negative sequence impedance is 5 ohm and zero sequence impedance is 5 ohm. Source voltage is 132 kV, and transmission line voltage up to fault point F, that is positive sequence impedance is 10 ohm. It is also negative sequence impedance, and zero sequence impedance is 30 ohm. The fault occur at point F. We'll draw a sequence diagram to calculate the distance in terms of impedance without Kz and then with Kz. And now fault occur at point F for rate phase to earth fault. There is a single line to earth fault occur at rate phase at point F. Now we first draw the zero sequence network diagram as shown in this figure. Here the positive sequence and negative sequence and zero sequence current are in series. Therefore I1 is equal to I2 is equal to I0 is equal to IR by 3. Now total impedance including the source impedance comes as 65 ohm. That is positive sequence impedance including line and source is 15 ohm. For negative sequence impedance including line and source is 15 ohm, and for zero sequence it is 35 ohm. That is 35 plus 15 plus 15 is equal to 65 ohm. Now the current, all the current are in series. Therefore I1 is equal to I2 is equal to I0 is equal to 132 by root 3 into 65 comes as 1172 ampere or 1.172 kilo ampere. Now V1R is equal to source voltage minus I1 into Z1, which is equal to 132 by root 3 minus 1.172 into 5, which is equal to 70.35 kV. Now V2R, that is the positive sequence impedance sensed by the relay, positive sequence voltage sensed by the relay is equal to minus I2 into Z S2, which is equal to minus 1172 into 5 is equal to minus 5.86 kV. Now for V0R, that is the zero sequence voltage sensed by the relay is equal to minus I0 into ZS0, which is equal to minus 1172 into 5, that is equal to minus 5.86. Now VR, that is voltage sensed by the relay for red phase, that is the faulted phase, is equal to sum of the all the sequence component voltage, that is equal to V1R plus V2R plus V0R, which is comes as 70.35 minus 5.86 minus 5.86 is equal to 58.63 kV. Now IR is equal to sum of the all the sequence component, that is I1 plus I2 plus I0, or equal to 3 into I0, since I1 is equal to I2 is equal to I0. Now the impedance sensed by the relay for fault at point F is equal to ZR without considering the factor the KZ is equal to VR by IR, which is equal to 58.63 divided by 3 into 1.172, which comes as 16.67 ohm. That is, the fault occur at the distance of 10 ohm distance from substation A end, but relay sense the fault at a point which is located 16.67 ohm from distance from A substation. That is, relay may underreach the fault location. That is why the KZ value should be introduced for earth fault location, earth fault, to calculate the actual distance of the fault location. So considering the KZ factor, here KZ is equal to Z0 minus Z1 by 3 Z1, where Z0 is 30 and Z1 is 10 ohm. Now KZ comes as 30 by 10 divided by 3 into 10, which is equal to 0.67. Now if I calculate the value of the impedance sensed by the relay with KZ, which is comes equal to VR by IR into 1 plus KZ. Since VR by IR in previous case, which is calculated, was 16.67, that is divided by 1 plus 0.67, KZ is 0.67, which comes is equal to 10. That is, actual fault distance can be calculated with considering the value of KZ, that is residual compensation of the earth fault. In the next video we will discuss about the calculation and the value of the R1 phase, R2 phase and R3 phase, and R phase to earth, R2 phase to earth and R3 phase to earth, and also the different value of KZ1, KZ2, KZ3, KZ4 with angle. So friends, if you like my videos, then do subscribe my channel and also press bell button for notification of videos to be uploaded in future. Thank you.